Well, up to now, we've traversed the process of a human interacting with a robot via voice up to the point where we have the text with what the robot wants to tell to the human. So we've visited automatic speech recognition, natural language understanding, and text generation. And so it's time for the final step, voice synthesis or voice generation. Traditionally, two methods have been used, concatenation methods and parametric ones. In concatenation methods, what we do is we first record real human speakers, and from their voices, we extract what are called phonemes. Phonemes are kind of atomic sounds, more or less corresponding to the sound of a letter. And with that, we create kind of a phonemes database. Once we have that phoneme database and we want to create voice, what we do is we get the text with what we want to say and look for in the database for the phonemes corresponding to the words, the letters in it. Concatenation methods tend to produce pretty natural voices, but are inflexible. Because if we want a new voice, we need to record a real human speaker again. On the other hand, we have parametric methods. In parametric methods, we do kind of modeling of voice or sound and reduce it to parameters. So when we want to create new voice, we just adjust the parameters. Parametric methods are flexible, but on the other hand, tend to produce robotic voices. But there are the traditional methods, but there are new technologies, new recent methods coming from the area of generative AI and foundation models that are improving the results. And some of that methods do not even use the intermediate text we generated with text to speech to text or in text generation and go directly. There are sequence to sequence alternatives in which we get by without that intermediate text generation and go directly from speech to speech, from what the human says to what the robot says. For example, a tachotron is a model that uses recurrent neural networks of the type LSTM, long short-term memory, and create time domain waveform samples. Or for examples are variations of transformers, the architecture behind ChatGPT, which receive phonemes as input, create embeddings from them, processes through convolutional layers and some additional processing, and in the end, we get an spectrogram and audio output. Well, all that has to do with natural language and voice is a very active research area. And I think we can expect great improvements in the next years or even the next month.